Welcome to Ask and Learn.
In the figure, we see that we have a force F pulling a single box. In the second case, we have that same force F pulling two boxes that each have the same mass as the first. And in the third case, we have the same force F pulling three boxes of all the same mass. And we want to rank the following from greatest to least: the acceleration of the boxes and the tensions in the ropes connected to the single boxes to the right in B and C. So let's draw our case with our single box here. And Newton's law, as we write, says that the acceleration is just the force divided by the mass. In the second case, we have the force acting on the two boxes. So we have that the acceleration of the two boxes is F divided by the total mass of the system, which is 2m. In the third case, we have the force acting on three boxes, each with the same mass. So we know that the acceleration is F over 3m, which says that the acceleration of A is greater than the acceleration of B, which is greater than the acceleration of C. If we look at the case where we split up the boxes, in the second case where we have two of them, we have a tension in between those boxes. So we cut the cable and we expose the force in that tension. So then we need to write Newton's laws for each box. We know that from the first case that the total force F equals 2 times the mass times the acceleration of the two boxes. We know that the boxes are accelerating at the same rate, so that if we look at the second box individually, we see that T1 must equal its mass times the same acceleration A, and that gives us that the tension in the cable holding them together is simply the applied force F divided by 2. In the third case, we have three boxes, and we'll call this one T1 prime in the tension between those two, and between these ones we'll call T2. Now note that T1 prime and T2 are not going to be equal, so don't make the implicit assumption that they are. Write Newton's laws for these equations, we see that we know from the first case that the total force equals 3m times acceleration. Looking at the second mass here, we have T1 prime minus T2 equals the mass of that box times the acceleration, which is the same for all boxes. And in the last case, we have T2 equals the mass times the acceleration of that box. We can then solve for T2 and find that that is the applied force divided by 3, and then find T1 prime, and that is 2/3 the applied force. So in the end, we get that T2 is the smallest, T1 is next, and T1 prime is the greatest.